Good afternoon, everyone. Today, me and Yuanxi will be presenting the project, which was in 2020 to 23 initiated by Professor Adair, who is the chair of the Division of Art History here at UW, and which in the frames of the HDSSI in 2025 was further developed by UNC and three other undergraduate students whose names are Trisha Agrawal, Stephanie Nagin, and Nur Hassan. The project is a part of scholarship which examines visual culture committed to the advancement of alt-right ideology. And by focusing on Peppa the Frog, originally a Bennigan character of a comics book and later a hate symbol due to its association with racist, anti-Semitic, and otherwise hateful expression. In the first phase of the project, we wanted to learn more about the strategies of its use across digital landscapes and Twitter in this case. Specifically, throughout 2024, we worked on a data set harvested by Professor Melanie Walsh from Twitter's Academic Research API shortly before it was shut down in 2023. And after close looking at more than 120,000 entries, we identified 3,471 specifically incorporating Peppa the Frog, whether through an actual illustration as a cryptocurrency or as a documentary footage of the January 6th riot. These 3,470 entries constituted our main working data set. Through close observation of each entry, we created metadata identifying if the visual followed a specific iconography and if it included a political or contextual reference. And here is our codebook, as you see, which includes 4 main dimensions. And as shown on the screen, we attempted to identify first whether Pepe had anything to do with either the current president of the United States, the January 6th riot, the crypto market, or the 2020 documentary telling its own history. Then we checked whether the content was abusive or hateful, and if so, in what regard. This is when we identified 8 subcodes related to ableism, body shaming, homophobia, transphobia, biphobia, misogyny, misandry, racism, and violence. Usual tweets belong to more than one category, and in such cases, we used ISD code, which stands for intersectional discrimination. Given the substantial number of entries of a sexual nature, we decided to create a specific metadata dimension to study this area in greater depth. And this is how the plus 18 codebook was emerged, including codes that indicate whether a tweet simply relates to sexuality or connects more explicitly with sexual objectification or pornography. And lastly, we sought to interpret the political alignment of each post by considering both the image and its accompanying text. And when we talk about accompanying text, we meant both. Sometimes texts are preluding the actual post, and sometimes they are part of the image itself. For example, many of you know the medium of green text where the text is next to the actual image. Here I have selected a couple of examples that illustrate like how we did this coding. The first shows a straightforward use of Smack Pepe, which is one of the iconographical type of Peppa the Frog, worn on a t-shirt by a right participant, and the text says above, Pepe made it to the Trump rally, which further sympathizes with the riot's violent agenda, qualifying this tweet as belonging to alt-right. The second, at first glance, an innocent crying frog also advances an alt-right agenda. The text not only expresses support for patriots, but also grotesquely mocks the motto, Black Lives Matter. The third is a typical example of crypto art or NFT with an obvious sexual connotation. And I also wanted to bring an example of an entry which kind of demonstrates leftist critique. Here you see the flag of Kyrgyzstan, a fictional alt-right country resembling the flag of the German Reich. Again, its text emphasizing the notion of white supremacy, again, signals the post-leftist critique, as I mentioned. In the second phase of the project, in the frames of HDSI this summer, we decided to measure the gap in the ability of different AI models and humans to categorize the political positionality, hate content, and sexual explicitness of tweets featuring the meme. The main goal was to see if AI could be a reliable tool for humanities scholars to study a large amounts of controversial image-based social media content. And then I give floor to Yuanxi, who will guide us through some technical details of the project.
Yeah. So let's start with the prompt. For our prompting strategy, we use the shot prompting because we give each model the full codebook, but no examples. This way, we can see the model, how it can do on its own and provide a baseline. We also build a chain of thought pipeline, and the model have to give quick explanation for their choice. So this help us not only see what they select but also why. So, and then we move to our experimental design. We decided to use those out-of-box models instead of the fine-tuning one because our target audience are like humanities scholars and students who need the tools that they can just pick up and to use. We test 4 different large language models in total. And for the cloud-based model, we use Cloud Opus 4 and Sonnet 4. Sonnet is a free available one through the customer interface on cloud. And the Opus one is a flagship model. On our test, both of them are quite robust, understanding the memes and also handle the image and text combination and pick up the labels we cared about. We also use the Mistral's Pixtral 12B as our open source option. This one ends up being our biggest technical challenge because Pixtral is pretty inconsistent. Sometimes they even make up some new classification tags. We tried to make a more specific prompt, but we didn't fully stop this behavior. And finally, we test the Lava Next, which is run fully locally, and we run it on the Hayek, the supercomputing cluster at UW. It's really helpful, highly recommended. It is it's actually did well in the visual interpretation, but it has a issue that sometimes it gives us a full explanation and without the classification. And let's talk.
Tableau?
Yeah,
Oh.
let's talk about the result.
Okay. Okay. Oh.
Oh, yeah. And this one shows that how human annotators and different large language models classify the political position. As we can see that human annotators, which is first, the left one, first one and second one, they assigned left or right political labels more freely than the large language models. For example, 58% of left tags and 73% of right tags are assigned by human. And LLMs are more cautious in political tagging, even in the case that for a like human perspective, there is a lot of clue about the political position. And while distinction between human and LLM performance were clear for political position, there is less for the hate/abuse categories. All the readers are instructed to identify just one of the 7 hate or abuse tags per tweet if it's relevant. And the codebook allow them to indicate whether it's encouraged or referenced. So encouraged is more like encouraged, but reference is just about like relevant or just mention about it. So this figure shows that in 5 categories, human annotators, they detected the encouragement most often and followed by 2 outputs, 2 cloud models. And the picture didn't assign any tags entirely. And interestingly, the LLMs, especially the Sonnet 4 and Cloud 4, their lack of encouraged tags by applying more referential ones. In other words, human annotators labels a tweet with actively promoting hate or abuse, and large language models, they tend to downward the severity and just use the reference one instead.
Yeah, we have kind of the same picture when it comes to sexual tags. As Yuanxi mentioned, like again, the main difference between encouraged versus reference is that, like, for example, if the LLM and first of all the human raters would see a post which actively promoted racism, then we would apply the tag which is racism encouraged. If in the entry there was just the discussion about racism, then we would just say racism ref, which stands for referenced. And as Yuanxi mentioned, like the LLMs prioritize the tag reference rather than encouraged. And we see kind of the same kind of carefulness with the sexual tags, while humans were more like would more freely incorporate tags like pornography or sexual objectification along with more general sexual tag. The LLMs would prioritize the tag which is like simply sexual tag without going into the details whether the entry was about objectification, pornography, and so on. And then we also calculated, actually, Trisha, another undergrad student, was curating this part, the iterator reliability. And here, as you see, like we based our analysis on Cohen's kappa for each pair of raters, like humans, but also the other 4 LLMs. And Cohen's kappa is, as most of you probably know, is like the indicator. It is like from -1 to 1, allowing us to measure degree of agreement and disagreement between the raters. And across most categories, the 2 human raters show the highest agreement, especially for hate, abuse references, sexual references, and contextual references, with kappa scores around 0.8 to 0.9, which is kind of near perfect agreement. By contrast, the political position category showed lower agreement between even human raters. And within each category, the 2 cloud models also demonstrated relatively high consistency. We describe the whole process and the findings in detail in an article which is now under the review process. We submitted it to the Journal of Cultural Analytics. And the article highlights the fact that LLMs, especially even the high-performing ones, tend to water down the intensity and responsibility for controversial content. The cloud models were reluctant to use accusatory tags like, as I mentioned, encouraged towards hate or abuse or pornography in terms of sexual tags. And they instead preferred the reference tag or simply sexual content. This caution is likely due to the guardrails, which minimizes the sense of personal agency and responsibility attached to the circulating politically sensitive material. While LLMs can process complex multimodal content at scale, their potential to augment human research is currently constrained by inconsistencies. This is like what we came up with, especially in open source models that remain undetectable without close human review. And actually, our project once again kind of highlighted the fact that maybe digital humanity, first of all, stands to the balanced merger of two approaches, which is like close looking, and then the other more like statistical approach of broader data. This was, I guess, all that we could talk about today, and I hope that the article will be soon published.